We're here to talk about the rainwater treatment trade. So I've got some slides here, and I'm going to talk about what really happens in a rainwater system. It's quite different to a mains water supply system where the treatment plant is at end of line, and there's a lot of focus on end of line treatment. In the case of rainwater harvesting, there's a natural process in the system that makes it work. I'll start with an introduction to the Australian situation to explain why this is true. Over 2.5 million Australians rely on rainwater tanks for drinking water supplies, possibly 3 million Australians. More than 6 million Australians use rainwater for some use, and there's no evidence of widespread health epidemics or impacts at all. So most of this rainwater is so-called untreated rainwater, the mains water industry tries to talk about it as. So the question is, why aren't people sick if they claim that people are going to be sick? And Australia is like a very large experiment that's gone on for 100 years. People have drank so-called untreated rainwater for a very long time, and they're not sick and they're healthy. So clearly there's a mechanism in place to make sure that's the case. So in many cases, rainwater is used for non-drinking uses in urban areas, and that can significantly change the security of regional water supplies and to improve the health of waterways and reduce flooding. However, there's ongoing speculation about the quality of and potential of rainwater supplies since the 1880s, ironically since we first had our centralised utility water supplies. So this presentation provides key insights from a decade of research into rainwater supplies, and it explains the rainwater treatment train. In recent times, in the last decade or so, we've had a number of epidemiological surveys, health surveys, to test the proposition that rainwater makes you unwell, or that rainwater doesn't make you unwell. Jane Hayworth did 2 studies. The first one looked at the risk of attaining highly credible gastrointestinal symptoms, diarrhoea, in 4 to 6 year old children, about 6,000 of them, and found those children using so-called untreated rainwater were less likely to be ill than those drinking utility mains water. This was a surprise, and the mainstream industry didn't believe Professor Hayworth, so she did a second study and found the same result. And this was for Adelaide, and it was argued perhaps Adelaide's utility water supplies aren't so great, but then they're filtered and chlorinated. So since then there's been 12 or 15 other studies, all found the same results. So all the health surveys show that so-called untreated rainwater does not produce a health impact worse than of drinking utility mains water supplies. The last study was of Rodrigo and others from Monash University, and they found that the risk of gastrointestinal illness, diarrhoea, was no different for households drinking treated or untreated rainwater. So the health surveys are saying drinking so-called untreated rainwater is no worse than mains water supply. So we need to be asking why that's the case. In 1998, my PhD research started on a place called Victory Place, and the picture I'm showing you now of what was supposed to be a rainwater storage, but because no one understood rainwater storages and the local council or water utility installed it, it was actually an underground stormwater detention tank, and as you can see, it's in a garden. The concrete in the tank has got holes in the roof and sides, so whenever it rains, soil and leaves into the tank. You can see from this graph that we measured more than 40 or 50 contaminants, potential contaminants, but this shows a selection of the key ones. So we've got fecal and total coliforms, which are indicator organisms for potential contamination by bird poo and other issues. Heterotrophic plate counts, HPC, is all organic fixing bacteria, which is most bacteria. Pseudomonas is particular bacteria that's associated with soil. And then we've got ammonia and nitrates, lead and zinc. So from the roof, Fig Tree Place, which is in the middle of Hamilton, in Newcastle, which is a high density inner city area, next to a bus station with about 3,000 bus movements a day, and also adjacent to an industrial area back in those days was BHP. So there was a lot of industrial and urban and traffic pollution around this site. So as you can see from the roof, there's a range of microbial indicator organisms, and there's ammonia, nitrate, lead and zinc. You can see from the tank water surface, so these were samples taken from the stored water, but at the very surface, you can see coliforms and the heterotrophic plate counts have increased, and that's not because of contamination of the roof water by bird poo or something like that. It's simply because soil is washing into and leaf debris is washing into the tank every time it rains, and that is stored on the surface of the tank. You can see as you go down into the physical and metal parameters that the numbers are quite less. As we go to the point of supply, which is near the bottom of the tank, you can see that there's no fecal coliforms, so there's no indicator organisms for contamination of the water from bird poo or other similar things. There's far less of all the microbial indicators, and there's less for the metals and physical counts, ammonia and nitrate. The end result with very low numbers is for the hot water service. What we found in this site over a 4-year monitoring period and hundreds of samples is a treatment train. As you can see, as you go from the roof through to the point of supply or the hot water service, is vastly improved water quality.